Today, we are going to see about the basics of per phase analysis of a symmetrical three-phase system. So first, let us comes to the introduction of per phase analysis of a symmetrical three-phase system. So so in unbalanced problem, what we are going to do is we are going to operate in a operator, sequence A operator. So all, say for example, R, Y, B phase that we are converting into only one phase. Say for example, it is A, B, and C phase. So that phase, what we are doing is we are converting that into only one phase. That is a phase. So that operator is called sequence operator A. In unbalanced system, to find the relationship between the phase voltage and phase current, we use this sequence operator. That is, say for example, we mentioned as A, B, and C. So all, and we mentioned the phases A, B, and C. All three relations we are writing in terms of A, that is sequence A operator. So this operator is called A operator. An operator which will turn a phasor through 120-degree in three-phase problems. So the phase angle between the one phase and another phase. A and C phases 120-degree. C and B phases again 120-degree, and B and A phases again 120 degrees. So each phase is okay. Each phase will have the phase angle of 120-degree apart. Okay, 120-degree apart. So in this figure, the phasor angle OA represents the reference voltage VA. Then OC which is equal to OA, that is advanced by 120-degree. The same OA which is advanced by 120-degree. Okay, so again, which represents A into VA. So here it is VA means here it is A into VA. Similarly, OB is further advanced by angle of 120-degree and equals to A squared VA. So here it is A into VA. Here again one more A is going to add. So it is A squared VA. So this is the representation of the phasor, that is VA, VB, and BC. But here what we are doing is we are converting this one voltage into, say for example, VA into, VB in the terms of A into VA, and BC in the terms of A square VA. So we are converting all into one operator, that is sequence operator. Then further we have, so you may have one question, why we are going for the sequence operator, A operator. So why? Because calculation is easy. Calculation is very, very easy. Then say for example, if you go for VA, VB, VC and all, VB, VC and all, so more calculation every time you need to. So if we are converting all into one scale, means in terms of A and VA, so our calculation is easy. And also while drawing the single line diagram, say for example, three-phase system will be there. So that three-phase system also we are drawing in a single line diagram. So in single line diagram, we can easily represents the voltage like VA is this, VB is in terms of VA, AVA, in terms of VC, A squared VA, like that easily we can represent. So that also one of the reason. So here A is equal to E to the power of J into 120-degree. That is the angle is 120-degree. So E to the power of J 120-degree. That is 1 plus J into 0 plus J into 120-degree. Next A square. A squared at the angle of J into E to the power of J into 240-degree. 240-degree we can write it in terms of minus J into 120-degree also. Next A cube is equal to E to the power of J into 360-degree. So 360-degree we can write it as 1, because here it is 120, here is 240. So here it is 360. 360-degree will have 1. You can tell us 1. So a plus a squared plus a cube is equal to 1. So if you add all these things, this thing and this thing gets cancelled, and this one will be there. So that is also 0. Okay, so a plus a squared plus 1 is equal to 0. So in Cartesian coordinates, in terms of this is in phase angle format. So in terms of polar form, that is in Cartesian coordinates, if you take your scientific calculator and convert this into polar format, so it will become minus 0.5 plus j into 0.866. Next, a square is equal to minus 0.5 minus j into 0.866. Next, a squared plus a plus a squared plus 1 is equal to this we need to add. That is minus 0.5 plus j into 0.866 plus minus of 0.5 minus of j into 0.66 plus 1. Okay, so this and this will get cancelled, and this minus 0.5 and minus 0.5 becomes minus 1. Minus 1 plus 1 becomes 0. So a squared plus 1 is equal to 0. So what are the significance of A operator? Significance of A operator on rotating the symmetrical component of the one vector by 120 degree or multiples of 120 degree, we get the symmetrical components of other vectors. That is, A operator can be defined as rotate 120 degree in anti-clockwise direction. If you see this phasor diagram, you can tell it is in anti-clockwise direction. So clock will always rotate in this direction, right hand side direction. This is in the anti-clockwise direction. So that's why. So here you see 120 degree, the terms of anti-clockwise direction. So A is equal to 1 at the angle of 120 degree. So that if you convert into 1 at the angle of 120 degree, if you convert that into polar format, polar format, so sorry, complex format. So it will becomes minus 0.5 plus j into 0.866. So significance of A operator, important 2-mark question. Say why you are sometimes why you are mentioning the in the sequence operator A, or why we are maintaining the only one operator, why we are going for a common operator. So that kind of question also they may ask in 2-mark. So that everything so in the significance you can write this also. The same thing is explained here. So you can write more points if you add all these things together. Then it will be for 2-mark. They will put a full 2 marks. You'll get full 2 mark instead of simply explaining. If you explain somewhat more with the representation, with the phasor representation, you will get full marks. So this is one of the important 2-mark question, sequence operator and the significance of operator. That is A operator, and what is a sequence operator. So together they will ask, or simply they will ask only the sequence operator or significance also. So if you ask about sequence operator, you can write significance also. So you'll get full marks.